All right, so we're going to talk about indirect measurement. Let's stop talking, guys. We'll talk about being outside. That'll be almost as good, right?
No.
All right, so indirect measurement is something, is a one way that we can use similar triangles. So I'm going to give you a couple of examples of how we measure things indirectly using similar triangles. So we're going to do a couple of examples. So for this first one,
What is that?
you have a friend who lives near a lake, and your friend
It's pretty rare in Colorado.
on one side of the lake.
I live that lake.
On one side of the lake, there's a picnic table, and on the other side of the lake, there is a tree. And your friend wants to know. Your friend happens to be a swimmer, and he wants to know how far it is across the lake to the tree. So if he wants to swim from the picnic table to the lake, he wants to know how far that would be. But he can't figure it out. Hmm? Well, he wants to swim across the lake, but he wants to know how far it is first, so he knows how far he's swimming. And your friend can't figure out how to measure it. He thought of putting a Garmin in his pocket and getting the distance that way, but then he tried that, and the Garmin short-circuited and stopped working. So he knows that you are a really smart geometry student. So he asked you, how do I figure this out? And you, being the smart geometry student you are, say, I can figure out how far it is across that lake. So here's what we're going to do. This is a very serious real-life situation. You get in your car because you have a driver's license, you like driving, and you drive this direction, and you make sure you drive at a 90-degree angle to the line across the lake. And then you turn at another 90-degree angle and drive a little ways out this way. And you make sure this is a 90-degree angle.
What?
All right? You guys are smart geometry students. This is what you did.
Probably look it up on the internet.
So what you do, it's in the mountains, so you can't get service.
That is entirely bullshit. Yeah.
Um,
Oh, I understand now.
All right, listen up. Shh. Then we sight. In the back of our car, we have some powerful binoculars. And we sight from where we stop driving across the lake to the tree. And we make a note of where our line of sight crosses here. And then, well, you like driving, so you're driving around. It's a Prius, so you didn't use much gas. And you look at your odometer. You look at your odometer. They're tough cars. Listen up, guys. You look at your odometer, and you realize this is 10 kilometers. You're using the kilometer part of your Prius because you know that's what you measure if you're being scientific. That's 10 kilometers. Yes.
That was a Prius in the mountains.
They're very hardy cars.
What?
GPS is
And we realize that this is, well, we don't know how far this is. This is how far we drive. This is 3 kilometers.
How do you know how far you drive?
Your odometer.
Why wouldn't you just drive on the side of the lake?
Because you don't know where you'd have to start here and you'd have to go around.
No,
So
you
you
should
didn't-
like drive out to like the edge of the lake and then drive across and then just see how far you can. Logically.
There's big mountains here, so you can't drive over there.
You're making this
It's in a canyon and you can't get past.
Right.
You're there.
All right, listen up. Let's finish this problem. Listen up. So you look on your odometer and you measure these distances and you tell your friend, now I can tell you how far it is across the lake. And your friend still doesn't believe you. So you say, well, take a look at these triangles. These two angles are 90 degrees. What kind of angles are these? Vertical angles. So they are congruent. So what do we know now about these two triangles? They are not congruent, but similar. So the triangles are similar by angle. So that means their sides are proportional. So we can set up a proportion between the sides. So I'm going to compare x over 10, this side to this side, equals 5.4 over 3. And your friend's still not impressed because he's not very good at algebra either. So you have to show off your algebra skills. So you say, I do this by cross multiplying. What's that? Well, he wants to make sure that he's a good swimmer, but he's not a great swimmer. So if it's too far, then he might get out in the middle of the lake and drown if he's swimming. So 3x, when we cross multiply, 10 times 5.4 is 54. Divide by 3. And let me rewrite my 3's. And x equals 18 kilometers. So you just measured your friends across your friend's lake indirectly using your knowledge of geometry. So now your friend's impressed. So you start getting a reputation as someone who knows how to measure lakes.
Are you drawing this out as you go?
What's that?
Are you drawing this as you go?
Yeah. So now you have a reputation as someone who can measure lakes. So now you're famous, and you go to another lake.
Oh boy.
Any questions on this indirect measurement? All right. So now you're at another lake, and you have a reputation. So this is a new lake. And the person wants to know how far it is across this lake, from here to here. It could be bigger. All right. We want to know x, but you want to impress your friend. You want to impress your friend. So this time you get in your car again, and you drive. I'm going to do this in red here. You drive straight out this direction. Straight along the line across the lake. And on your odometer, you measure that. That's 25 kilometers. You really like driving your Prius, so you drive a fair amount. 25 kilometers. Yes.
All Priuses have GPSs.
We're up in the mountains where you can't get reception.
There's reception.
I guarantee there's not reception here.
Yeah, you don't need reception.
You have to have line of sight to the satellites. All right. And now we're going to drive. Now we're going to drive this direction at a 90-degree angle. This is 90 kilometers. You were really into driving your Prius today. Priuses don't take very much gas at all. And now you get out your powerful binoculars and you sight across the lake again. 90 kilometers. We sight across the lake again to the convenient tree that's on the other side.
That oh so convenient single tree.
Not quite. We're not quite done. Now, there's one more thing because you're a really smart geometry student. You know there's one more thing we need. Now you go back to the shore of the lake, and from this point, you drive over here to the line of sight, and this is a 90-degree angle. And you measure that distance on your odometer. That's 75 kilometers.
How did you narrow your journey?
You mark it. You put a stick in the road to know where you started and stopped.
He doesn't have
Yeah, the GPS went out of the Prius, and you have to use the analog odometer. So now, you can't get cell service there.
What about little satellite phones?
All right.
We will make this work.
So now being smart geometry students, you say, now I can figure out the distance across the lake. And the person says, well, how do you do that? So you say, well, look at these two 90-degree angles. So I have a big triangle here, and it has a 90-degree angle. And I have a little triangle here with a 90-degree angle. And look right here. They both share that angle. So the triangles are similar by angle. Let's stop talking, guys. The triangles are similar by angle. So our sides are proportional. So let's set up a ratio between the sides. I'm going to say, for the small triangle, the base is 75. So I'm going to say 75 divided by 90. This side of the small triangle and this side of the big triangle equals, this side of the small triangle is x. How big is the big side of this triangle? 25 plus x. And now we can figure out how far it is across the lake. Your friend, this particular person is not very good at algebra either. So you need to show off your algebra skills. We cross multiply. What's that? Yeah, that's why they live in the mountains next to a lake. So now we're going to show off our algebra skills. Shh. We're going to distribute here, 90x. Your friend doesn't know what distributing is, so you have to show what that means. 90x equals 1875 plus 75x. And now we almost know how far it is across the lake. Subtract 75x. And we get that 15x equals 1875. Divide by 15. And finally, we know that x equals 125 kilometers. Wow. I never realized they had chips in the bathroom.
I didn't.
So we know that the distance across this lake is 125 kilometers using similar triangles. So now you have a great reputation as a person who measures lakes. To the drawing. Well, we don't know how far it is across. We don't know this length. Then this part goes through the lake, so we can't figure out that distance. Yes. Yeah, that wouldn't change the distance.
But it kind of would.
Maybe because when you're swimming, yeah, maybe.
Well, would it also depend
If the
on
wind was
speed
blowing.
of the water?
Yeah, I guess so. All right, any questions on our indirect measurement? All right, we have one last thing to talk about today.
Does it have more to do with lakes?
Not directly.
And there is a lake somewhere.
Sam. All right, so more similarity theorems. All right. So what we're going to talk about now is just a couple more things that we can do with similar triangles, a couple more parts of triangles that we can compare. So our theorems, guys, let's settle down. I know you're excited about measuring lakes, but let's settle down.
Oh yeah. Favorite part of the day.
If two triangles are similar, then their altitudes and their medians are in the same ratio as the sides. So we'll draw a couple pictures to remember what altitudes and medians are, and then we'll do some examples. But if we know that triangles are similar, then we know that their medians and their altitudes have the same ratio as sides. So here are our triangles. And altitude goes from the vertex at a 90-degree angle to the base. Guys, shh. This is an altitude from the vertex to the base at a 90-degree angle, and a median. The median goes from the vertex, and it cuts the opposite side in half. So this is going to be congruent. So the altitude goes from the base at a 90-degree angle to the vertex. The median goes from the base, from the middle of the base to the opposite vertex. So this is an altitude, this is a median. So let's look at some examples using altitudes and medians and similar triangles.
Wait, what was this section called? More at the top.
Oh, at the top, I just said more similarity theorems. So these just give us another part of the triangle that we can compare using proportions. All right, are we good?
Yep. Good.
All right. So here's our example. Our two triangles. And we'll draw in the altitudes here. And we know that the triangles are similar. And this is 9, and this is 6. This is 5.25. This is 6 and 4, and this is x. And we want to find x. So our triangles are similar. So we know that the altitudes are in the same ratio as the sides. So we can make a ratio between the sides of the triangles and set that equal to the ratio of the length of the altitude. So I'm just going to pick, I'm going to say 9 divided by 6, this side divided by this side, equals 5.25 divided by x. So I'm comparing this side and this side, and this side. Cross multiply, 9x equals 31.5. 6 times 5.25 is 31.5. Divide by 9, and x equals 3.5. So this just gives us another ratio that we can work with when we know that our triangles are similar. I could compare any of the sides of the triangle. I could say 6 over 4 equals 5.25 over x. I could say 9 over 5.25 equals 6 over x. I can set up my proportion in a lot of different ways, but I'll get the same answer no matter what I do. Questions on that one? All right, let's look at one with medians. So here are our triangles for this one. And I'll do my medians in blue. And what tells me that these are medians is that these two segments are congruent. I want to undo that. So it divides this side in half. And we know that the triangles are similar. And this side is 5. This side is let me switch them around. This side is 7. This side is 5. This side is x. And this side is 4. So the blue segments are the medians because it divides this side in half. We know that the triangles are similar, so our medians are in the same ratio as the sides. So I can say 7 over 5 equals x over 4. Cross multiply, 5x equals 28. Divide by 5, and I finally get that x equals 5.6. So it just gives me another thing to write a ratio with and compare it to the ratio of the sides of the triangles. And I could set my ratio up in lots of different ways, make my proportion. I could say 7 over x equals 5 over 4. I could say 4 over 5 equals x over 7. We end up with the same thing no matter how we do it. Any questions? And if we happen to have this triangle that's around a lake, then we'd be able to figure out how far it was across this lake. All right.